Okay, guys, so this is going over the lesson for 8.4. This doesn't say 8.4 here, but I'm going to put it just so you know. Okay, the reason I'm doing this one is that so many kids messed up on it on the last test. So on this side, these two things have to be equivalent. Sine of 75, sine 1/2 of something. So this is solving by half angle. So we have to use half angle formulas on this. And so that's where we use plus or minus the square root of 1 minus cosine of something all over 2. Because it's sine, you have to use a minus sign. And the cosine number here is 150. This is the number that was on the unit circle, and that's what we're taking half of. Okay? But then I want to go ahead and explain real quick that to choose positive or negative comes from the 75, or it can come from half of 150 because half of 150 is still 75. Either way, that's in quadrant 1 and it's going to be positive. Now the first thing you have to do is substitute in for the cosine of 150, which is negative square root of 3 over 3. So it's 1 minus the negative square root of 3, not over 3, it's over 2, all over 2. Now we can't add these until we have a common denominator, so this is going to become 2 over 2. And so our top piece is going to be the square root of 2. Now what happens with these double negatives? They become a positive. So this becomes 2 plus square root 3 all over 2 and all of that over 2. Well, whenever you have the 2's like this, then I'm going to put this over 1 and then inverse and multiply 1/2. Okay, this is now gone, and that gives me, so I end up with the square root of 2 plus the root of 3 all over 2 times 2 is 4. I have to still have the root of 4. So this gives me final answer 2 plus the root of 3 all over 2. Okay, notice I still have this square root right here. A lot of people wanted to leave that out, and a lot of people wanted to delete that plus sign. You got to keep it. It's part of the problem, okay? It doesn't turn into a multiplication, which was common. All right, on number 2, I don't know how many people wasn't sure how to do this, but you put it over 1. And one person told me today when I asked how to do it, they said, well, you want to reduce the 2, multiply the first 2 together. Well, if I do, the 2 reduces with the 4 and it becomes 2. And then secondly, the 2 on the end, because it's on a numerator, reduces with the 2 in the denominator, and it leaves me with a grand total of 3 over 5. Okay? All right, going on down. Okay, this looks very similar to the graph we had the other day, but notice this ends at 2 pi. It's really hard to see on your screen. I promise this is 2 pi, and this is pi right here. Okay? And I said, look at the difference between this and this one. Look how long it takes this one to complete a full period. It only takes pi units to complete it. So if we take a range of 0 to 2 pi for our answers, then what's going to happen is you're going to have an answer here, an answer here, an answer here, and an answer here because our 2 pi, it's right here. And so we need all of those answers. So now we have more than just the 2 answers. We have 4 answers. All right, so keep that in mind. Now the way that we're going to do this is, notice that when we're at 1/2, if you use the unit circle, sine of 1/2, I've got my unit circle handy, is going to be at pi over 6 and 5 pi over 6. So that means 2x is equal to pi over 6 and 5 pi. over 6. Okay, there's my 2 places, and that's as if it were equal to x and not 2x. That's these 2 answers right here. Okay, I just want you to realize that. So then I'm going to rewrite, and I need some light colors here. I'm going to rewrite this, and I want to find the general solutions. General solutions, well, let's go over here to the side first and say, you know, we need to know what our solutions look like. Wow, that looks like a really bad coordinate plane. I'm sorry, I am trying to do this with this tablet. Let's try it again. Well, it would help to have something to write with. Okay. Oh, look at there. That looks a little bit better. Okay, so if sine is pi over 6 and 5 pi over 6, it's something along these lines. Now, what I want to point out is that for me to get back to this point, I have to go 2 pi. And the same thing is true for this one as well. For both of these, I have to go 2 pi around, no matter which one I'm looking at, and that's going to get me back to the original. So I want to know if I add 2 pi to this distance, I would end up here. Sorry. So let's just look at this. Let's look and see what's going to happen. So I'm going to rewrite 2x equals pi over 6 plus 2 pi n. All right? And pi over 6, 2 pi equals 5 pi over 6 plus 2 pi n. Okay? So there's my 2 equations using this, this, and this, and I'm almost done with it, but not quite. So what I have to do is I have to divide. I'm going to change color so you can see this happen. I'm going to divide by 2 or multiply by a half, whichever's easiest. Divide by 2, divide by 2. You could say this is divided by 2 because I multiplied the bottom by 2, and 2 there. So what it leaves me is these are my general solutions. I get this cancels, and I get x equals pi over 12. This cancels, I get plus pi n. And this cancels. Oops, this was supposed to be an x, not a 2 pi. That was a 2x. All right, this is supposed to be x equals, I have 2 times 6 here, so 5 pi over 12 plus 4 pi n. Almost said over 12. I've got so happy writing over 12s. All right, so this is part of it. Now, I'm going to see if I can get another light or color to do in here. Hang on. I've got yellow. This bright green will help me. Okay, so the next thing I'm going to do is I want to find all the solutions. Now, this is important. The general solutions are important because I need to know where n is equal to 0. Now, when n is 0, here's my n. All of this would go, every bit of this would go to 0. So I would have x equal to pi over 12. And over here, I would get x equal to 5 pi over 12. So that's our first 2 solutions that are easy. Okay? Those are not our only solutions. So what's going to happen is we need to find out what's going on when n equals 1. So if I have n equals 1, then for x, I'm going to get pi over 12 plus pi, because now this n right here, that n becomes a 1. So that's plus pi. Now, you should know to be able to add these two, I have to have a common denominator. Well, pi, let's go down here in the corner, pi is the same as 12 pi over 12. I don't think anybody has a hard time believing that. So that means all of this goes to 13 pi over 12. Okay, on this one, I get and x equals, now I'm going to be adding 12 pi over 12 again because n went to 1. 12 plus 5 is 17 pi over 12. Now, if I go any further past 17 pi over 12, if I add another 5 to it, I'll be at 22 pi over 12. Oh, that actually works. How is that right? I'm double checking myself. I thought I should only have 2. Did I do something wrong? Did I add 12 to it? I did. Oh, I didn't add 12. I added 5 to this. If I add 12 to this, I'm going to be at 29 pi over 12. These are my answers. If you wanted to check, this is checking. If n equals 2, x is going to equal pi over 12 plus 2 pi. Now hold the phone. If I am adding 2 pi to anything, won't it be bigger than 2 pi? I added it to pi over 12. Too big. So if it's too big, I don't need this one. All I need are these 2. So let me show you all of my answers. This is an answer. This one's too big. Oh, good grief. I need another color. Let's see if this shows up in gray. This is an answer. There it is, gray. Gray are my answers. This is an answer. And this is an answer, and that's an answer. Mine's a little pushed for space, and then all of this is considered an answer. That's what I would be getting points for. All of that. And I also want to see this. I'm going to be giving you points for this drawing as well. There you go. All right, so now we're going to try this with enough room to where we're not going to be running out of space. So to solve this one, I would divide both sides by 2, and I get cosine of 3x equals 1/2. Lost a parenthesis. Let's fix it. So where is cosine 1/2? Cosine is 1/2 at pi over 3. So 3x is equal to pi over 3, and I've got another friend for it. Nope, not 2 pi over 3, 5 pi over 3. I got to keep them positive, and I'll show you why. 5 pi over 3. It's one of the things I get points for. So over here, I would have pi over 3 is one of my answers. The other answer is going to be down here at 5 pi over 3, because that's where cosine's positive, okay? So now the question is, could you take and add pi to one of these and get the other one? No, can't happen. So what you're going to do is you would have to get from here all the way back to here, which is 2 pi more, because it's doing loops going around and around, because that's what a sine and cosine curve do. They don't do loops, but they do the cosine curve. Okay, so that means I'm going to have to split this. So I get 3x equals pi over 3 plus 2 pi n. And I get 3x equals pi over 3 plus 2 pi n. All right? Now, because I want to solve for x, I'm going to divide every part by 3. And this is going to end up a 3 down here and a 3 here. And this side gets it as well. Okay, hopefully I can still read all of this. So my general solution, GS, I'm going to have, okay, this cancels. It leaves me x equals pi over 9 plus 2/3 pi, or 2 pi over 3 n. And x equals pi over 9. That shouldn't have been another pi over 3. That should have been a 5 pi over 3. I just caught it. I should have used this one right there. So 5 pi over 3, 5 pi over 9. My gosh, I multiplied by 3 on the bottom, plus 2 pi over 3n. Now, that means we need to see, now that's all the possibilities of what's going to happen with this. Guys, if you want to, I just won't even go there. I'll just tell you, I can show you a cool way to make sense of this, why it works this way. All right, so once you have this, what happens when n equals 0? Well, that's easy. X is equal to just, if n right here goes to 0, then that means we have just pi over 9. Or x equals, if this is 0, if that is 0, I have to underline it. I don't know if my cursor shows up. Then that means we have 5 pi over 9, even though I tried my best to make it something else. There you go. There's your two possibilities. Well, what if n equals 1? If n equals 1, the value that I'm adding to this is 2 pi over 3. I'm going to show you right here. But adding 2 pi over 3 to a pi over 9 is not all that easy. I need a common denominator. So this is equal to what over 9? Well, that means I have to multiply this top number by 3. So it gives me 6, and this is my magic number. Okay, because 6 pi over 9 is exactly the same thing as 2 pi over 3. Okay, and n, when n is 1, I need to add 6 pi over 9 to the original number 1 time. So that means for this, if I add 6 pi over 9 here, I'm going to get 7 pi over 9. Or if I add it to this side, if I add 6 pi over 9 here, then I'm going to get 11 pi over 9. And you're saying, wait a minute, why'd you do that? Because I'm letting this become 0, 1, 2, etc. Okay? So when n is 2, what am I going to get? Well, I would get x equals, now I'm going to add another, remember the heart, 6 pi over 9. So I'm going to add 6 and 7 and get 13 pi over 9. Now, if you want to double check, 13 over 9 is just a little bigger than 1. It's not bigger than 2. So we're good. Or x is equal to, now I'm at 11 pi over 9. I'm going to add 6 pi over 9 to that one as well. So that's going to give me 17 pi over 9. And we're getting really close to 2 here because 18 over 9 is 2, and that would give me 2 pi. So this is as far as I can go. Notice I had to plug in 3 times, and my number up there is also a 3. So all of my answers, I'll use the highlighter, all of my answers are here, here, this, I'm glad I'm using the highlighter. I ran through a couple of them. And this. If you want to know what I'm looking at on the test to grade your points, that's what I'm looking for. Now this one, we didn't get to do this in class. I purposely skipped it. So I am going to go ahead and do it because it's long. And I may ought to pause the video, or you may ought to pause it and come back to it later, look at the time on it or something. So I have the secant of 4x equals 2. Now, this wouldn't be a big deal if it were just the secant of x, but it's still not that bad. It's 1 over cosine 4x equals 2 over 1. And then I'm going to take this and flip both sides and get cosine of 4x equals 1/2. So I've got some answers where 4x, what 4x could be, and for it to be 1/2 for cosine, it's pi over 3 and 5 pi over 3. And so where that's going to show up over here is up here in this quadrant, down here in this quadrant, okay? So this is going to be adding 2 pi. This is a 2 pi n problem. All right, so then I'm going to go back to, I've got 4x. That's where I'm looking for. Okay, so for the general solutions, I have 4x equals pi over 3 plus 2 pi n, and I got real happy with that e, and I can't talk to my daughter right now. And 4x equals 5 pi, I'm doing the right one this time, over 3 plus 2 pi n. Okay, I know this is going to take some room, so I'm trying to take as little space as possible. I'm dividing everything by 4. 4 and 4. Okay, so let's clean it up. X is equal to pi over 12 plus, this reduces to a 2 pi over 2 n, and that cancels. X equals 5 pi over 12 plus pi over 2. That canceled to a 2. N. There we go. The whole kit and caboodle. There we go. You know what, guys? I said something in class, and I apologize because somebody goes, I don't even know what that is. And to be honest, I probably don't either. And that made me think of kit and caboodle because I don't know what a kit and caboodle is. Maybe somebody out there does. You can tell me what a kit and caboodle is if you know, but I don't. Okay, so now that I have that, I want to let n equal different things. So I'm going to start with n equals 0. Now, guys, notice I have a 4 right there. So n has to be 0, n has to be 1, n has to be 2, and n has to be 3 because I need 4 answers coming out from each equation. So I'm going to have 1 on one side, 1 on the other. I'll get my 2 ands in there. Okay, so this one's easy. This is where x is 0, so it's just pi over 12. And this one's easy. It's just 5 pi over 12. We get the first one. Yay! We get points for that. Now we've got to look what happens when n is 1. All right, so I'm going to go over here and figure out, I'm wanting this to be in twelfths. So that means I need 6 pi over 12. And that's the same as pi over 2. All right, so that's what I'm going to add each time. So if this is worth 1, I'm actually adding 6 pi over 12. So that will give me 7 pi over 12. Just so you know, I am adding, and I'll do it here too, I am adding 6 pi over 12. So if I had 6 pi over 12 when n is 2, then I'm going to get 13 pi over 12. If I add it again, then I'm going to get 6 and 13 is 19 pi over 12. Okay? There's my answers on that side. I'm going to go down this side. That was 0. This is 1. This is 2. And this is 3. So on this one, and it's really pushed for space here, adding 6 to 5 is 11 pi over 12. Adding 6 to 11 is 17 pi over 12. Adding 6 to 17 is 23 pi over 12. There's all my answers, and this is my beautiful number right there. Okay, so my next set of solutions are all of these and all of these, and of course my general solution and my drawing to help me right there. Okay, all right, next problem. Well, we'll try to get the next problem. There we go. All right, kids love this one in class because it was short and sweet. Let's get this one filled in. So all we had to do here was either multiply or divide by -1. Whichever one you want to do, it means that negative ends up over here, and then that one becomes positive. So I have cosine of 2x equals -1. Now be careful. The cosines, these negative and positive one business, that's where it messes people up. So remember, cosine comes first, so that happens over here. This is where we have -1, 0, and this is cosine sine. And I mean, a lot of people get confused with this. So this is where 2x is equal to pi. Now, how much is it going to take for me to get back to this to repeat this answer in another, further on down the line, I should say. It's not the different quadrant or axis, it's the coterminal angle. So this is a 2 pi problem. It's 2 pi, I'm gonna be adding. So when I set this up, well, you know what? I can use this because I don't have another one. I can just say plus 2 pi n. Now, what I have to do is divide everything by 2, and x is equal to pi over 2 plus pi n. All right, there's my equation. So I'm going to go in, I'm going to let n equal 0. And if you do, x equals pi over 2. And if I let n equal 1, x equals, well, I need to add pi to that. And if it bothers you and you're like, I want my nice one, I want an over 2 pi. Well, 2 over 2 pi is the only thing that would work, right? So add 2 over 2 to 1 over 2, and now I have 3 over 2. So 3 pi over 2, and if I let n go to 2 because I'm just in the mode, and I'm like, okay, keep going. If I add 2 more to this, I get 5 pi over 2, but wait a minute, that's 2.5 pi. This one's too big, I didn't need it. Now, if you leave it there and you don't mark it out, you'll lose points for it. So be careful, make sure you mark it out and tell me it's too big or erase it. Okay? Next problem. All right, this one, I'm actually going to switch it around if you don't mind. I want to do this one first because it doesn't take up much room. So I'm going to have 2 cosine x plus 1 equals 0. And on this one, I'm going to have cosine of 2x equals 0. All right? So if I'm doing this one, I have to subtract 1, and I get 2 cosine x equals -1, divide by 2. So cosine x equals -1/2. So I'm going to look, where's 1/2 for cosine? It's at pi over 3. So that means I need to go to quadrants 2 and 3, and that puts me 2 pi over 3, 4 pi over 3. So this one, x equals 2 pi over 3 and 4 pi over 3. Now the question comes up, do I need a general solution for this? No, because in this one, x was just an x, and I solved for cosine of x, And I'm done. So these are 2 of my answers. I'm not done. I've only done half the problem. I have to do the other half. Okay, so when I do this one, actually I'm going to go with green. All right, so when I do this one, I'm going to get 2x equals 0. Okay, wait a minute. That means I got to go in and find the cosine. Where is cosine 0? Cosine is 0 at pi over 2 and at 3 pi over 2. So if I graph this, pi over 2 and 3 pi over 2, hold the phone. Do you notice that these 2 points are pi distance from each other? So that means I get to write the equation with only pi n and not 2 pi n. So I've got 2x is equal to pi over 2. I use the top one. This one's pi over 2. Plus pi n. Now, if you forget that this one gets to be pi n and you write 2 pi n and then you do another equation for this point, 3 pi over 2, if you do another equation for that one with 2 pi n, it will work. You'll just have an extra equation, and that's okay. Just telling you, it will work. All right, so now I'm going to clean this up and get my general solution. I'm dividing by 2 every part. This cancels, so x is equal to pi over 4 plus pi over 2n. Now, what is the sweet number? We'll put a little heart by it. What's the sweet number that would combine with pi over 4? 2 pi over 4. And that's our counting number. That's when we have n is 1, we'll add a 2 pi over 4. When n is 2, we'll add 2 pi over 4s, and you use the number before it. So to find those solutions, like I'm talking about, n is 0, then our solution, x, is just pi over 4. When n is 1, watch this. This is so cool. When n is 1, it should end up down here. If we add pi to pi over, we're adding 2 pi over 4. We will get 3 pi over 4. Just kidding. X equals 3 pi over 4. When n is 2, that means I'm going to add another one. This is where I'm adding them. Plus, plus, to get my next number. So x equals 2 plus 3 makes 5. 5 pi over 4. 5 pi over 4, we're not near the end yet, are we? I don't think so, because we can go to 8 pi over 4. So n equals 3. X equals 2 plus 5 is 7. 7 pi over 4. If you went one more, which is, by the way, going to be too far, x would equal 9 pi over 4, and 8 pi over 4 is 2, so this is too big. Too big. You didn't need to do it if you had recognized how close you were here, that you couldn't add any more to it or you would go beyond, then you could have stopped. So what are my answers? The ones that I have highlighted already. Whoops, I don't need the end part as an answer. This is what I'm looking for, and this is what I'm looking for. Okay? Those are all the answers I need. Well, and I'm also going to give you points for this because I want to see it. Okay? And that's it. So we're done. Have a great day, guys. I hope this helps.